So, welcome back, students. Today we'll discuss about lab activity 7B in Linux configuring file system permissions. So, file system is a mechanism by which the data we can organize in a storage medium like hard disk, and the file system manages all the files and directories in that hard disk. Okay. How do we configure the Linux file system permission? We use a utility or command called as UMASK for configuring the permissions. What is UMASK? UMASK is a utility will decide what are the default permissions to be given for a file and directory when it is created. Okay. It's a 4-digit octal number that configures Linux as which of the three permissions are to be denied or not granted. Okay, I'll show you the example. And UMASK value for normal user is 002 and for root user it is 022. Okay, so 002 and this one is root is 0022. How you are getting this value, I'll show you. Okay, so this is the first thing. What about file system? Mechanism or method by which the data like files and folders are getting organized in a data gets organized in a medium. Okay, so this one, the file system manages all files and directories in the hard disk. So to set the file permissions, okay, so setting file system permissions in Linux, we use the command umask. So for normal user, umask is 002 and for root user is 0022. How we calculate this one? I'll show you this one. So here read, write, execute, three permissions are there. So for read, we have the value 4, write 2, execute 1. Okay. How do we calculate umask value for normal user? So for normal user, the theory is like owner can do both write and read permissions on a file, and group can also do both read and write permissions. But for other user, only read is allowed, write not allowed. Okay. So whenever you are writing that numbers, okay, first part will be for owner, then group, then other user. So owner of the file, as per the theory, for a normal user, owner of the file has read and write permissions on the file. Okay. So I know when you write this combination read, write, execute, first thing will be read, then write, then execute. So the owner has read and write permission. That's why 4 plus 2, 6. Read, write, then hyphen. Group also, as per the theory, for a normal user, group can also perform read, write. So 4 plus 2, read, write, 6. Other user can only perform read. Read is 4, right? So 4 plus 00. That's what only 4 and the permission is read only. Okay. Now, UMask will identify which of the three permissions are not denied, okay, or to be denied or not granted. Okay, so here we will consider, see, first permission, second, third. Okay, so for owner, 2 are there. Okay, out of the 3. Okay, like usually we have execute, we don't give execute permission for everyone, so we'll go for read and write. So for owner, read and write allowed, so everything is allowed means we put 0. Group also everything is read, write allowed, so we'll go for 0. Okay, and for other user we have given only read, write is not there, write value is 2, that's why we give 002. See, the value is 002 now. What are the permissions? Read, write. Okay, take it, read, write. Out of this read, write, which are the permissions not granted? That will come here. Here both are granted, so 0. Group, both read, write granted, so 0. Nothing to be granted. Now other user read only granted, write not there. Write is 2. That's why 002. For root user, the mask will be 022. Means owner only read and write the files. Group and other user don't have write, only read. That's why for the owner it will be read write is allowed. So 0. For group only read allowed. So 4 we have. So what is not there? Write. So 2 is there. Other user read only permitted. For owner, okay? Owner means root user. Normal user is okay. For root user, again 2 comes because other user can only read, write not allowed. Okay, if you ask me to draw this for root user, just draw you. Control C, I'll show you how to do that. Okay. So for owner, I have read and write. For group, I have only read permission. So this one I'll put 0. Here R only allowed. Write and execute not allowed. Other also same. Only read allowed for other user. Okay. So when you take the UMASK, they will take the one which is not granted. So here read write both granted. So it will be for owner it will be 0. Group only read allowed. Write not allowed. So what is the value of write here? 2. That's why 0, 2. Other user also we have read allowed, write not allowed. Write is 2, right? So that's why 0, 2, 2. Clear what I'm telling? This is what how we calculate UMAS value for normal user and root user. Okay, root user. Done. Now go back to our activity. I want to go to the desktop folder. I want to create an empty file by using touch command, and I want to display the permissions of empty file. Display and observe UMAS value for user and how permissions assigned by Linux system for a new file. Let's see. Okay. So I'll go back to my editor. Okay. So PWD, as I am using the online editor, I don't have the desktop folder like in your Linux machine, virtual machine. That there you can type that PWD and you can find desktop folder. See here, you can find desktop. I'm already in desktop. Assume that I'm already in desktop, so I'm not doing that. Okay. I'll go for now creating a new text file that is empty. Usually we used to create a text file, how you create a text file. You go to the editor, you type echo, then you type the content, the Linux lab going on, something, okay? Then we have this redirection operator to write the content into file. So file dot text. Okay. This is how you create a file with content. This is the content, then file name. Text, right? Now I need to test the permissions. So I don't want to create a file with content. Just I create an empty file. Nothing is inside. For that, I have the command touch, then file name before dot text. Okay. I'll go for here touch before dot txt. I create an empty file. Nothing is inside. You want to test this? See cat touch dot txt. Sorry, cat. Sorry, before dot text. Okay, sorry, before dot text txt. So again, cat before dot txt. Nothing is inside because it's an empty file. Okay, now what is the next thing? Create an empty file using touch command. Display permissions of new empty text file. For that we have ls minus ld. Okay, ls you already know. This one we are going to display the permission on file or directory, both. Okay, so that's why ls minus ld before dot text. Okay, so I'll put this one ls minus ld before dot txt. See here, as we discussed in that theory part, for the owner, for the group, for the other user. For the owner, read write allowed. For the group, read write allowed. For the other user, only read allowed. Okay, that is a permission. See here. For the owner, read write aloud. That's why RW and 6. Group also read write aloud. That's why 6. Other user only read aloud. That's why 4. Now, how do we get this number? This 002. How do we get that UMASK value? I will just type UMASK here. Let's see. UMASK. You will get 002. Okay. So read write allowed for both owner and group, but for other user only read aloud. Okay, done. Now they mentioned this. See how you are getting this. UMASK value for Linux system is 002 for a normal file. So UMASK affected file permissions for normal user 666 minus 002. So here see user or owner has both read write. Okay. Group also has read write. Initially, okay, initially everyone will be given, see, all permissions initially, okay, but for the normal user, what we do, we have to subtract, or we know that this one is for normal user, it is read write aloud. For others or group, we have read write aloud. For others, we have only read aloud. That's why from this, we will subtract this one, and now this is the actual value you are getting. Read write for no, which one? Owner, read write for group, only read for who? Other user. Okay. These are the file permissions you have. UMAS value, the file permissions are like this 664. Okay. Now we are going to set the UMAS value as 000. Display the new UMAS, create a text file, display the permissions of text file, then observe the UMAS value and understand what are the permissions assigned. Okay, so here based on the UMAS, the permission assigned are read and write for both owner and group, and for other users only read. How you get that? Subtract 666 minus your UMAS value, you will get this one. Okay. This is default UMAS value for normal user. Now we go for changing the UMAS value 000. Okay. So here I am going to make UMAS 000. Okay, you check this UMAS set as 000. Yes. Now what they're doing, they're creating a new file, empty file, I am 000.txt. Okay. Touch I am 000.txt. Now check the permissions. ls minus file permissions minus ld. What they are doing here? They are giving both files, the previous one and current file. Okay, before.txt and I am 000.txt. Checking file permissions of both. Okay, before.txt, I am 23.txt. See here for before.text, the first text file, read write for owner, read write for group, other user only read. For I am 000.txt, read write for all, owner, group, and other user. How? How this new file permission is built? Because the UMASK is now 000. So what happens? See the calculation here. 666. Okay. We subtract with UMAS 000. So we'll get the same value. That's why everybody will have read write permissions. Okay. Then we have this is done. Now we have UMAS value 444. Okay. So what you can do is when you subtract 666 minus 444, you will get what? 222. Right? This one. only write permission. Okay. We'll try this. Set the UMAS 444. UMASK 444. That means read not allowed for anyone, only write. Check the UMAS set or not. Then what is the empty file name you want to create? Touch I am 444.txt. Touch I am 444.txt. Now I'm trying ls minus l, list all files. Read write for owner and group and read only for other user in before.text. The second one we had UMA 000. So all the read write permission for owner, group and other user for I am 000. I am 444 means only write permission allowed for owner, group, other users. Clear what I'm telling? Now, see how you get that. 666, that's a basic calculation, okay? Read write for all owner, others and groups. From that, what is the UMAS value? Subtract that one, then you will get the exact file permissions, okay? Then UMAS value 777. So here UMAS 77 means 666 minus 77. You cannot get negative value, will make it 000. So that means no permission for anyone. Like owner also don't have any permission on the file. You cannot read, write nothing. Group also cannot read, write nothing. And others also can't do anything on the file. Okay. Let's try that one also. File name is IM777. So here I'm going to test UMASK 777. Display the UMASK. Yes. Now touch I am 777.txt ls minus l. See the last file I am 777.txt, no permissions here because I give 777. That means don't give anything for owner, user and group. Okay. Then task 4. So configure UMAS value for user as default. Then delete all unnecessary files from your system. Just I'm deleting all this, okay? How do you write, how do you delete the content? That's what asking. Okay, so just I'm going to reset the default value of which one? UMask to 002 for a normal user, right? Not root user. So UMask, now make it UMask 002. Now try. Okay. Now I want to remove the users, okay? What are the users now? Not the users, remove the files, okay? RM, remove the file RM, okay? Followed by the file name. Before the text, I am 00, I am 444, I am 777, okay? So I'll go for remove the file RM, okay? So before dot txt, I am 123 0.txt. I am 444.txt. I am 777.txt. I'm going to remove all these empty files. Just I was testing the file permission for these files. I don't want it to be kept in the files or directories or folders. Okay, just I'm deleting all those things from the file system. Remove, yes. Now ls minus L 0. They removed all those files. Okay. That's what about lab 7B. How do we set the file permissions? Okay.